let's decode the logarithm of 5 to the base 5 to the base 6. This is represented by a variable x, and we are going to show the result of this. Take note that we have here the logarithm of 5 to the base 5 as the coefficient intended for the outside logarithm to the base 6. So let's start by solving first the value for the logarithm of 5 to the base 5. Now we can attack this in two different ways. The first one is let us try to equate this into something else, let's say variable y. And let's try to apply the transformation of a logarithmic equation to an equivalent exponential equation. It follows this idea. Whenever you have a logarithm of a to the base b, and let's say this is equal to, in this case, y, we can rewrite this logarithmic equation into an equivalent exponential equation in this manner. The base b there will also become a base. This y is the exponent of base b, and the coefficient here is equal to your exponentiation. This is the value, or the transformation rather, of this logarithmic equation, this form to this form of an exponential equation. Now following that, we can apply here this. So you have here base 5. This would be your exponent y is equal to the coefficient here, which is 5. And here we can use the property of equivalent exponents, which tells us that if you have two exponentiations, let's say a to the power of m and a to the power of n, they have the same base, we can say that the exponents are also equal to one another. So you have a to the power of m, a to the power of n, same bases, take out the exponents and they should be equal. Here we know that 5 has exponent of 1, which tells us that the value of y is equal to 1. But this is not yet the final result, for this is just a representation of the first logarithmic equation, which is the inner of the two. I mentioned two different ways to solve for y here because this can be represented under a property. In a property of a logarithmic or logarithms as a whole, if you have the logarithm of a coefficient to the same base, just like this, logarithm of 5 to the base 5, this is automatically equal to 1. Even if you will not equate it to y, automatically, if the coefficient here is just equal to the base, it's automatically equal to 1. Now let's proceed to the solving of the entire expression. We have here the logarithm of 5 to the base 5, okay, to the base 6, and we represent this as x. Okay, we know this to be equal to 1 already because this is represented by y, to which we solved earlier as 1. In short, you have here the logarithm of 1 to the base 6 is equal to x. Let's apply the transformation. You have 6 to the power of x is equal to 1. What do you think is the value for x here? Now, the bases are not the same. Therefore, there might be some cases where we cannot apply the property of equivalent exponents. But here, 1 can be a representation of any exponentiation of the same base 6. Because you can write it here that 6 to the power of x is equal to 1. In terms of base 6, that's 6 to the power of 0. Okay, again, we have 6 to the power of x, 6 to the power of 0. They have the same basis now, but 6 to the power of 0 is automatically equal to 1. Hence, the value of x, which is the entire expression earlier, is equal to 0. Using the property of equivalent exponents, same basis, you need to equate the exponents. So this is now how we decode the given. And that is mission accomplished.